Here we have a Rosemount Model 3051 differential pressure transmitter connected to a hand pump where we can apply air pressure. We have this transmitter powered by a 24-volt power supply. We're measuring the current using a Fluke 87-4 meter, and we also have the current going through a 250 ohm resistor. We're going to do a simple exploration of 4 to 20 milliamp current loop and how this transmitter responds to pressure. The range of the transmitter currently is 0 to 1,000 inches of water pressure. And we are currently measuring, 0%, which is a 4 milliamp signal. It says 3.99 on the meter, but we're supposed to be at 4 milliamps. We're close enough for a test. What I'll do is gradually apply pressure to the transmitter using the hand pump. And as I do so, you can see with the meter, the current starts to go up. As I approach 12 milliamps, that'll be the halfway point of our 4 to 20 milliamp scale. And at that point, we will be at about 500 inches of water column pressure. There we are, 12 milliamps, and it's holding pressure with our pump. What I'd like to demonstrate to you is how this current, this 12 milliamp current that we see, is dependent only on the amount of pressure we apply to the transmitter and is not dependent on other factors like loop resistance or power supply voltage. For instance, watch what happens when I begin to change the voltage here. It's now 24 volts, we have 12 milliamps. Watch as I decrease the voltage from 24 down to about 20. Notice the current doesn't change at all. That may surprise people who are accustomed to DC circuits, where you are used to applying Ohm's law, current is equal to voltage divided by resistance. In this case, however, we are not dealing with a simple resistive circuit. We're dealing with a transmitter that has a current regulator built inside of it. And the purpose of that regulator circuit is to maintain or to throttle the current in the circuit according to how much pressure is being applied to it, not according to how much voltage is being given to it by an external supply. I can even turn this down further, from 20 volts down to about 15, and still our current holds steady and true at 12 milliamps because we have not changed the pressure at the transmitter. And the purpose of the transmitter is to regulate current according to whatever process variable it is measuring. I'll go down even further. Let's go down to about 12 volts. Still, we're holding at 12 milliamps. Let's go down even further. At this point I'm about 9 volts, and you can see my current has dropped well below 12 milliamps. At this point, I'm not applying enough voltage to the transmitter terminals for it to successfully operate. And this microcomputer inside the transmitter is having problems. And that's why we see the current bounce up and down. The microcontroller is trying to power up. When it does so, it drops more voltage through this resistor, it loses operating voltage and powers back down. So we have kind of a weird cycling action right now. If I turn the power supply voltage up high enough, that behavior stops. Here we can see it stopped at about 10.6 volts, and now the transmitter is able to function properly. If I increase our voltage back to the original value of 24 volts, we see that the loop current is where it should be, about 12 milliamps. If I increase the voltage further beyond 24 volts, it still holds true at 12 milliamps. Now we're seeing a 12 and then 11.9 because I've lost a little bit of air pressure, so I'm going to increase the pressure just a bit to hold us steady at 12. But I'm trying to demonstrate that the loop current you see in the circuit is really dependent on the pressure we apply to the transmitter and not to the voltage. Also, I'd like to show how if we bypass this 250 ohm resistor in the circuit, that likewise has no effect on the loop current. Watch this. I'll disconnect it and then bypass it right there. So we were connected right here. I disconnected the wire. Now I'm bypassing the resistance, and watch, 12 milliamps. I can turn the voltage down to about 24 volts. Once again, 12 milliamps. I can reconnect my resistor back in the circuit, 250 ohms, and we're still at 12 milliamps. Like I said, this is surprising to people who are familiar with DC circuits. Most people would expect the loop current to change as I alter the supply voltage and or alter the loop resistance, but this does not happen because this is not a simple resistive circuit. The transmitter contains a current regulator that will regulate the current at whatever value represents the applied pressure, which is our process variable.